Alright guys, so in this problem, a heating cooling problem, we're going to be looking at the heating system for the building shown below, okay, and how it can raise the temperature 10 degrees Fahrenheit at a rate of 200 cubic feet per minute. Basically what that means is for us to go up 10 degrees Fahrenheit, okay, we have to wait 1 minute for every 200 cubic feet. Okay. So we'll talk more about the rate in a little while, but we're being asked to figure out how many minutes it will take to raise the temperature of the entire building 15 degrees. Okay. And we are going to answer this to the nearest minute. Okay. So the first part that we need to kind of take care of with this is we probably need to discover how big the building is. Okay. So in this case, we can go ahead and take a look at the shape of the building. Okay. And we should see it as kind of two parts. Okay. We see the rectangular prism. Okay. And we know that a rectangular prism is basically width times depth times height. And we can see that width, depth, and height of this one are going to be 20 feet by 20 feet by 60. Okay. So, calculator-wise, we can go ahead and clear out some of the old data, but 20 times 20 times 60, and we end up with a volume for the rectangular prism to be 24,000 cubic feet. Okay, remember, units multiplied together just like the numbers multiplied together. Okay. Now the trickier part in this one is going to be taking a look at the rectangular prism. Okay. Now the formula for that, and you can look at formula sheets or some other sources, but basically this is the area of the base times the height divided by 3. So in this case, we know the area of the base is basically 20 feet by 20 feet. That's the area part. Times the height. Okay, the height in this case is 21. And then we'll divide that by 3. Okay. So 20 times 20 times 21 divided by 3. Okay. And this is going to be 2,800 cubic feet. Okay. So the total here is basically 26,800 cubic feet. So knowing the total size, okay, the next part for us to kind of look at is the rate, okay, what we established earlier, the rate of change. Okay. So we're needing basically 1 minute for every 200 cubic feet to raise the temperature of 10 degrees. Okay, so 10 degrees, 1 minute. We'll kind of segment that for the amount of space that we need. Okay. The reason that I want to kind of segment that is that we know that in a unit conversion, if we have 10 degree Fahrenheit change, okay, and we can use the delta symbol, that basically means change, over 1 minute, okay, we know that that's the equivalent of 1, okay, because we can also flip it around. 1 minute will be equal to that delta change of 10 degrees Fahrenheit. Okay? That's just an important concept with our conversion factors. Okay? But the reason we talk about that is we can also scale it upwards. Okay? If it takes us if we only turn the heat on for 30 seconds, we should be talking about a change in, 5 degrees for that same 200 cubic feet. Okay? We can kind of shift these numbers around a little bit as needed. Okay? But effectively speaking, we're also saying that if we just scale up both sides, okay, 1.5 minutes, okay, basically 90 seconds or a minute and 30 seconds, is going to be the same as that 15 degree Fahrenheit change for that 200 cubic foot space. Okay. Now, heat in thermodynamics is something that we'll usually cover midway into principles of engineering, but in this case, we're really just looking at this as a conversion factor. We can, if you know the Newton's laws of cooling, we know that there's always going to be looking for that equilibrium. So even if we're just hitting up one 200 square foot space in a larger building, the heat's going to dissipate and everything eventually is going to kind of balance out. Okay? So what that allows us to do is we can go ahead and start kind of factoring in how much space, okay, how many of those unit blocks do we need to have? Okay? So if we take that 26,800 cubic foot space and divide that by our 200 cubic feet, okay, we're basically getting rid of those units, and we're saying that we have to repeat kind of that temperature change. So okay, we're basically having to convert that 134 times. Okay? And we can kind of consider it spaces as cubes, something, we're changing the unit because we're basically recognizing that we're having to, kind of augment that so we can go ahead and kind of apply it to this concept. Okay? So not knowing the starting temperature, not knowing anything else, just knowing that we have to raise the temperature of the building 15 more degrees, whatever it's at, we need to figure out how many of those, we figured out that 134 200 square foot or cubic foot blocks, okay, that we're basically going to say, okay, to get that 15 degree change, we're ignoring that now, and we're basically saying 134 times 1.5 minutes, okay, to get the changes that we're desiring. Let's see, so we discover that this is going to take 201 minutes. Okay. This is partially an engineering problem. It is something that you kind of see in a math case, but the key here, okay, and hopefully you were kind of catching it, is the subtle details of the rate of change, okay, knowing that 10 degrees for 200 cubic feet takes 1 minute. Okay. That could be the same thing as saying that 20 degree change for a 200 cubic foot space is going to take 2 minutes. Okay. But we're balancing those things out, okay, adjusting it for the end goal of that 15 degree change, okay, taking 1.5 minutes of that heating process. Okay. But then when they're multiplying that by the number of the 200 foot space or cubic foot spaces. Okay. So definitely a little tricky, can be a little hard to balance out, but recognize that, look for the volume, look for the rate, adjust the rate and the conversions for the space that you have. Okay? Not going to be the simplest process, but hopefully this has given you a few steps in the right direction. So if you're needing help, as always, leave comments, send questions. Remember that I'm here to help you out where I can.